Okay, Math 189, section 1011, inclusion, exclusion. Wait, is it 1011 or 1010? 1011, yes, okay. Video 4. Video 4, okay. All right, so this one I'm going to go over problem 4. Problem 4 from the worksheet. Problem 4 from the 1011 worksheet. Okay, so just like with class time, I had meant for this to be something that you worked on a little bit before and thought about a little bit before I went over it. So best case scenario would be for you to turn this video off right now, try problem 4, then come back and see what I do if you get stuck or you get an answer, see if you got the right answer, okay? I'm not going to do every part, but this problem will set you up for problem 9. Problem 9 on the worksheet. So you understand this one, you can do problem 9. Okay. All right, so we're going to count the number of rearrangements of a string. What that means, so in this case we have the string 1 1 1 1 2 2 3 3. So here's our string. So how many different ways can you rearrange this string where you get at least 2 consecutive equal digits? Okay, so let's see, one way, so let's look at, so first rearrangements. So some rearrangements of this, string. Let's see. How about, let's see, 2, 1, 3, 3, 1, 2. Okay, this is a rearrangement of that string. Right. And notice that this one does fit, this is one of the ones that contains at least 2 consecutive equal digits. Okay, so there's this one. A rearrangement of this thing is itself. I know it seems weird that we consider a rearrangement of that to be itself, but it is a rearrangement. It's a really boring rearrangement. Okay, and you can see that this one does fit the bill as well. It has it has at least 2 consecutive equal digits. It actually has 3 consecutive equal digits. All right, let's write 1, 1, 2, 3, 1, 2, 3. Okay, here's a rearrangement that doesn't fit the bill. It isn't a rearrangement with 2 consecutive equal digits. Okay. Okay, part A has 3 parts. Part A has 3 subparts. I, 2i, 3i. So we're going to count the number of elements of A1. A1 is the rearrangements that have the block 1, 1. Okay, so we're going to rearrange these things, but so some of the things in A1, let's see, 2, 1, 1, 2, 3, 3 is in A1. Another thing that's in A1, let's see, 2, 3, 1, 1, 2, 3. That's also in A1. These are rearrangements of 1, 1, 2, 2, 3, 3 that leave the block 1, 1 fixed. And you think of this as a block of digits. Okay. So we start by counting the number of different positions that the block 1, 1 could go in a string of length 6. Okay, so a string of length 6, we got 1, 2, 3, 4, 5, 6. We got 6 positions. Okay, so we could have 1, 1 be there, right? 1, 2, 3, 4, 5, 6. We could also have 1, 1 be there. 1, 2, 3, 4, 5, 6. We could also have 1, 1 be there. 1, 2, 3, 4, 5, 6. We could also have 1, 1 be there. 1, 2, 3, 4, 5, 6. We could also have 1, 1 be there. All right, so let's see. Does that exhaust them all? let's see. There's another way to kind of go about this. 3, 4, 5, 6. Okay, another way to kind of to look at this is to, so here's 1, there's 2, there's 3, there's 4, there's 5, right? So 1, 2, 3, 4, 5. So let's see, we had 1, 2, 3, 4, 5. Okay, so the answer to part A, let's see, you got 5, right? You could just draw this out, something like this. So you got 1, 2, 3, 4. Okay, 6 positions, right? There we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay. 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 Now suppose you fixed a position for the block, right? So you got 1, 2, 3, 4, 5, 6. You got 6 positions. You got 6 positions. Now let's see. Let's say we chose to put the block of 1s. Let's say we put them right there, right? Now this leaves 4 remaining positions, right? These 4 positions, 1, 2, 3, 4. For 2 2s and 2 3s. Okay, so how many ways can we distribute 4 2? How many different ways can we distribute 2 2s and 2 3s to 4 positions? All right, so you can kind of think of this as this becomes, let me give these names, say position 1, position 2, position 3, position 4, position 5, position 6. This becomes 1, 2, 3, 4, position 1, position 2, position 3, position 6. Okay, so here now we really just have 4 positions. Because once we decide where those go, the ones occupy positions 4 and 5. So then we have positions 1, 2, 3, and 6 left. Those are the 4 positions we got left. Okay. All right. So here the answer we've got 4 positions. Choose 2 of them. Let's say that to be 2s. Then we have 2 positions left over. Choose 2 of them to be the 3s. 2 choose 2 is 1. 4 choose 2. So you could actually just compute this if you want. It might be easier. Let's see. This is 4 choose 2. Let's see. You got 4 times 3 over 2 times 1. Right. Remember, that's always something to remember that. Let's say you got 4 factorial, what is it, 2 factorial, 4 minus 2 factorial. This is 4 times 3 times 2 times 1. 2 factorial, or just 2, 2 times 1. Here we got 2 factorial, which is 2 times 1. Those will cancel. 4 times 3 over 2. We could do all that work, but just to remember, you can always just remember that n choose 2 is n times n minus 1 over 2. That's really the number of handshakes. When n people shake hands, or in this case, 4 people all shake hands, right? So we got 2, answer is 6. Okay, so for this one, the answer is 6. So for part 3, of part A, subpart 3 of part A, now we multiply them together. There's 30 different ways that this will work out. Okay, so the cardinality of A1. See, there's 5 different ways you could put the blocks, right? So for each one of those 5 different ways, there's 6 different ways that you could rearrange the 2 2s and the 2 3s. So you have 5 different ways to put the block of 1s, times 6 different ways to rearrange the 2s and the 3s once you pick one of those. It's 30. Okay. All right. This is kind of a fun one. I like this. Okay. So A1 intersect A2. This is rearrangements that leave 1, 1, that leave the blocks 1, 1 and 2, 2. Okay, 1, 1 and 2, 2. All right. Okay, so first thing we're going to do, and I did actually write this, okay, so, but I haven't looked at it since last semester, so that's why I'm having to kind of read through it a little bit. But I did actually write this worksheet. Okay, first consider the case where the 2 remaining 3s form the block 3, 3. How many strings in there have the repeated block 3, 3? Okay, so we're trying to say how many strings in the, so 1, 2, 3, 4, 5, 6. Let's start with the 6 positions. Okay, I like this one. This is fun. I remember this one was pretty fun. Okay. All right, so we got 6 positions. So in this first part, we're looking at how many different ways, how many different strings in here also have the block 3, 3 in it. All right. How to do this? Oh my gosh. Okay, I'll figure it out, don't worry. All right, we got 6 positions. Okay, so let's just go with the first one. Okay, so first consider the case where the 2 remaining 3s form the block 3, 3. Okay, how many strings in there also have repeated block 3, 3? Okay, so first thing, what do the things in here look like? They're rearrangements that leave the blocks 1, 1 and 2, 2. So you have 1, 1, 3, 2, 2, 3, that would be one of these. 3, 2, 2, 3, 1, 1, that would be in there. That's in that set. That's in that set. 1, 1, 3, 3, 2, 2, that's also in that set. Okay. So what we want to do is we want to think to ourselves, okay, 2 remaining 3s form the block 3, 3. Okay. The 2 remaining blocks form the block 3, 3. Okay. How many different strings in A1 intersect A2 have the repeated block 3, 3? Okay. So repeated block 3, 3. I feel like I should just Okay, so the question is, okay, where can we put this repeated block 3, 3? Okay, so we could put the 3, 3 there, right? notice that you couldn't put the block there, right? Because if you put the block there, then let's say we had 2, 2 here, then we'd have 1, 1 there, right? We can't put the 3, 3 there, so this can't happen. Also, that can't happen, right? So you see that? We can't have that situation. Right, so we can either put the 3, 3 there, we can put the 3, 3 there, or we can put the 3, 3 there, right? That's pretty much it, right? We can put the 3, 3 there, put the 3, 3 there, or we can put the 3, 3 there, right? That's it. If we put the 3, 3 there, we're in trouble. If we put the 3, 3 there, we're in trouble. That's really all the different places we could do it, right? Right, I think it was 5, right? There was 5 different possibilities for putting two symbols next to each other, right? They're this one, that one, and that one, right? There, 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 there. These two can't happen because if we put them like that, then we separate the ones or the twos. Right, you could have twos and twos, ones and ones, and then we wouldn't be in there. Okay, so we have this situation there, right? So. Okay, so if we have a 3, 3 there, right? Notice that, okay, so here with this part, right, we're just saying how many strings in here also have the repeated block 3, 3, right? So we just established that the 3, 3 can either go there, or it can go there, or it can go there. Okay, so there's 3 different possibilities there. Now we're going to have rearrangements where we have blocks together. We have the blocks 1, 1 together and the blocks 2, 2 together. So you can think of these as basically, this is like, you can either put 1, 1 there and 1, 1 and 2, 2, or 2, 2 and 1, 1, right? So for each of these 3 possibilities, so we have 3 places for the 3, 3 block. Whichever of those 3 places we choose, then we have, because we're putting them in blocks together, right? We can either have 1, 1, 2, 2, or we could have 2, 2, 1, 1, right? There's no other way for things to go. So you can think of it as basically you have, this reduces down to 2 positions, the 2, 2s, and then the 1, 1s, or you have the 1, 1s and the 2, 2s, right? You can think of those kind of collapsing down into just 2 positions, right? So once you choose one of the 3 places for the 3, 3 block to go, 1, 2, or 3, then you multiply that by, you basically have 2 symbols and 2 positions. Right, the 2 symbols are, this first symbol is 2, 2, and the first symbol is 1, 1, second symbol is 2, 2. All right, so you have 2 positions, 2 positions, 2 symbols to choose from. The 2 positions, in this case, let's say like P1, P2, P3, P4, P5, P6. Right, once we choose those, then the problem becomes, becomes 1, 2, 3, 4. P3, P4, P5, P6, but we want to put 1, 1, 2, 2, or 1, 1, 2, 2, or P3, P4, P5, P6, 2, 2, 1, 1. All right, so same thing. This becomes this one becomes, you have, right, in this one you would have P1, P2, P5, P6, right? And you could do 1, 1, 2, 2, or 2, 2, 1, 1. The same thing here. You'd have P1, P2, P3, P4. You'd have, let's see, P1, P2, P3, P4, 1, 1, 2, 2, or 2, 2, 1, 1. Right, so this first one, right, we have the answer is going to be 3, right, because there's 3 different ways we could put the blocks of 3. And then once we put the blocks of 3, once we choose which block of 3 we're using, then we have 2 places that we could choose for the 2 2s. Or think of it with the 1s, maybe like the 1s better. 2 places to choose from. So you have 2 basic positions, either here or here. 2 positions, choose one of them for the 1s. And then a 1, right? Because once you pick, let's say we picked those 2 there, then those 2 are determined. Okay. So part I, 3 times 2 times, otherwise known as 6, or 3 factorial. Okay, that's I. Okay. Okay. Okay, and then 2i, b, 2i. Now consider the case where the 2 remaining 3's are not next to each other. Okay, so 1, 2, 3, 4, 5, 6. Okay, so the 2 3's are not next to each other. Okay, let's see. Let's see, we could do this and can we do that and that? Well, that won't work, right? Because look, we're living in this world of rearrangements that leave 1, 1 and 2, 2 stuck together. Leave the blocks 1, 1, 1 stuck together and 2, 2 stuck together. So this won't work, right? That won't work. 1, 2, 3, 4, 5, 6. Similarly, a 3 there and a 3 there won't work. Okay, 1, 2, 3, 4, 5, 6. Let's see, the hint, notice that neither of these 3's can occupy, okay, block of 3's, no, okay. The 3's are not next to each other. Neither of these 3's can occupy the second and fifth position. So you put a 3 there, then we have a problem again. Let's see, that was the second position. 1, 2, 3, 4, 5, 6. Put a 3 in the 5th position, we have a problem. The two remaining 3's are not next to each other. All right, so I'm just going to write down all the different situations that could happen. All right, so this can't happen, right? That can't happen. Let's see, you have 1, 2, 3, 4, 5, 6. So here we're saying we're not looking at this one where the 2 3's are next to each other. Here the 3's are not next to each other. And we're going to get blocks of 2 1's, blocks of 2 2's. Okay, and so both of those, right? So if you could have a 3 here and a 3 here, that would be okay. Right, because then you have 2's, the 2 2's and the 2 1's, or the 2 1's and the 2 2's. 1, 2, 3, 4, 5, 6. Let's start with a 3 there. Let's see, you could have a 3 here, right? But then we'd be back up there, so that's not what we're looking at, right? Because we're looking at the place where 3's are not next to each other. You can't have a 3 there, right? Because then it'll separate one of the blocks of 1's or 2's. You could have a 3 there, that's what we have already. You could have a 3, could you have a 3 there? No, right? Because if you put a 3 there, then that separates them out, right? So we have like that. All right, so we have this, or we have this. 1, 2, 3, 4, 5, 6. Okay, all right, so let's see, what did I do? So I'm trying to be systematic about this. So I start with a 3 there, and I say, can I go 3 go there? No, because that's taken care of right here. Okay, can a 3 go there? No, because then we'd be separating the blocks of 1s and 2s. 1s or the blocks of 2s. Right, so no, so can we go there? Yes, that works. Okay, so that's one of them. Okay, now starting here again. We already decided we can't go there, we can't go there. Going there would be the same thing as that, right? So then, but this one won't work right there, so then that's the only thing there. Okay, now move along. Can we put a 3 there? We decided already we can't do that, right? Can't put a 3 there. Okay, now put a 3 here. Okay, if we put a 3 there, let's see. We could put a 3 there, but that would put us back up there, so we don't want that, right? We could put a 3 there, but then we'd be separating things out again, so that's not going to work. So we have that position as well. So we have that. Right. 1, 2, 3, 4, 5, 6. Okay, then you do like, okay, so moving on, let's see. All right, so let's see, like, now if you go backwards, right, and you put a 3 here, right, that puts us back up there again, so we don't want that. If you put a 3 here, then that separates a 1 or 2, the block of 1s or block of 2s, so we don't want to do that, right? So really we only have, that puts us up there, that separates them, so we really only have that option there. Let's see if we have any others. 1, 2, 3, 4, 5, 6. Okay, let's see. Let's put a 3 here. We can't put a 3 there, right? We just already decided that. Okay, right. So let's put a 3 there. If we put a 3 there, will that work? Let's see. We can't put a 3 there, right? Because we put a 3 there, then we separate things out again. If we put a 3 there, we can't do that because it separates things out. So does that 3 there make sense? Well, it only makes sense if you put a 3 there. Well, that's up there already. And it only makes sense if you put a 3 there. No, because that'll separate things out. Or you put a 3 there, but we already counted that one there. So that's not going to work. Okay. Let's move over. Does it make sense to put 1 there? No. Now put a 3 there. Okay. Now look at that. Okay. Does that make sense? Well, it does if you put a 3 there, but we already counted that one there. Does it make sense to put a 3 there? No. Because it separates things out. We'll put 1 there. That's already that one. Put 1 there. That separates things out. Put 1 there. That's already up there. So here we have our 3 different positions, 3 different situations here. I know. Okay, so part 3. So using both of these parts now, we're going to count all the things that can be in here, right? So we have 3 different situations, right? So, or 2 different situations. A1 intersects A2. Right, here we're basically using inclusion-exclusion again. We're using inclusion-exclusion again. Here we have 3, 3 together. The set where we have, this is part A, plus 3, 3 not together. This is part B. Now maybe you're saying, hey, you got to subtract where they have stuff in common. But here's the trick, right? They have nothing in common. They have nothing in common, right? You can't have a string, a rearrangement of 1, 1, 2, 2, 3, 3, where the 3 3s are both together and separate, right? Because there's only 2 to choose from. So if they're separate, then they're not together. If they're together, they're not separate. So in this case, we don't have to subtract anything off. So here our answer is the number that we found together, which was 6, plus the number that we found that were not together, which we found to be 3. You should go through this and check and see if maybe I missed one there. I don't think I did. I'm pretty sure I got them all. I was very systematic about it. But you know, this has been a long video. I got 9. Okay, So now we got these guys together. So we did A and B, and now use the work of A and B, noticing that when you go to compute part C, you're going to have the cardinality of A1 plus the cardinality of A2 plus the cardinality of A3. Notice that the cardinality of A1 the cardinality of A2 is going to be the same as the cardinality of A1, right? So I've really done all the work you need. I'm just going to be repeating the same ideas over and over and over again to get part C.